Okay, so yeah, so R is the software that runs in the background of your computer to help all the things you do on R work. So you need to download that. Then you also need to download this thing called R Studio. So this is like the world that you'll use R in. Ooh, what's this? R and Python, cool. Okay, so then you download R Studio here, R Studio Desktop. Download the open source one. This is the free one. Yeah, and then that's how you do it. So basically, you'll never actually use base R. So I'll show you what that looks like. So so see here I have R and R Studio. So if I were to open just R, it would look like this. And this is basically all that it has. So it's not really very intuitive. It's really hard to know what's going on. So what we use is this thing called R Studio. Which is a much easier environment to work in. And I'll kind of explain the sections of this because I know that's a little confusing. So this here is your script section, which you can think of as like a document section. So if you were to open like a Word document or something in Word, this is like your R script section. So this is stuff that saves, you can save this. And it also is like its own document. Here is your console. So this is console is where you actually work and do things, but you don't want to really write anything in here that you're going to want to save because you're going to want to write that up here. So like basic things you can do in the console are basically everything. So like say I wanted to just do 2 + 2, click enter and it gives me 4. If I wanted to assign that to a variable, like say I wanted to assign that to X, I would do this. And click enter, and then I can see here that this value pops up here in my environment. So this area is your environment, and this is where all data frames, all objects, all variables that you save go to. And then here, this is a few different things. So this is your files, so all the files on your computer, and you can kind of see that it's like, it's mirroring what is on my, my user computer. Then plots, if you're gonna make plots, they'll show up here sometimes. These are packages, and so what packages are like little add-on pieces of software that make R do different things when you need it to. So like base R has a lot of functions, but it doesn't have all the functions that you'll probably need to do different things. So you will want to install different packages that do different things. And then the help tab. So if you type help for any function, you can see what that function does, right? So like say I wanted to see what this function here does, read CSV, I would type question mark, read CSV, and then this help thing will come up here, which can be really helpful when you don't know what you're supposed to be putting in as arguments or what kind of data outputs and things like that. So here I can basically see that for read CSV argument, it wants me to put in the file, whether there are headers, whether there are like what separates each entry in the CSV. For most of these things, you don't actually have to put anything because there's defaults, and the defaults will usually work most of the time. So here you can just see that I just put in the data file, and then I put in strings as factors equals false. And that just means that I don't want my strings, which are text words. So like if I had a variable that was comparison early stress and it was in the data as comparison early stress, it would code that as a factor. So as a 0, 1. So do I want it to do that or do I not want it to do that? That's what true false means for that. Cool. So any questions right now at this moment?
This is all being recorded, right? So we could go back.
Yeah, but we can also edit out, like if you don't want your question to be in it or whatever, we can edit that out. So feel free to take up time. Cool. Okay, so the first thing we're gonna do is I'm going to close all this. Oh, one other thing I'll tell you before we start is that there's a few different types of files that you can read in here. You can read in plain text files. You can read in .r, which is an R script, which is what people usually start with. These are R Markdown documents, which integrate plain text in Markdown format and code chunks of R code. So I like to use these because they are good for reproducing what you're doing, because you can mark them up with like text that you want to comment on. Yeah, and then one other important thing, this means comment out. So first off, the only thing that's going to run in the actual R system is things that are in these code chunks that have this R thing here. This is an opening and this is a closing. So R is going to run everything in this chunk if I press this like green button right here. Except for things that are commented out, which you do with the hash. So if I want to write a comment, like read in the data, I'm going to put a hash before that, and it won't run that. That's just going to treat that as words. Things that are outside of the chunks, you don't have to put hashes in front of them to make them comments. But outside of the chunks, these hashes mean like header 1, header 2. So since it says 2 hashes here, it will display as like a level 2 heading. Okay. Okay, so now I'm gonna show you guys where the tutorial is. So I think, wait, did I post it? No. Did I post a link to this? I'll post a link if I haven't. Okay, so this is our BabLab GitHub, and you can see this tutorial that we're going to do today in this link. So I will send this in the chat. How do I do that when I'm screen sharing? I'm just going to send it in the Slack. Yeah. Who knows? Okay. So I want you to like keep this page up, but also click this green button here and click download zip for this file. So I'll do that.
Recording, it only records my Zoom, right?
I think so.
Guess we'll find out.
So you said click what?
Click this green thing and click download zip. All right, so then what I'm going to do is I'm going to find that and I'm going to put it on the desktop. And then I'm going to unzip it and just delete the zip. Okay, so you can keep this up though to follow along as we go. So what you want to open from this folder that you just put on your desktop is this R Markdown file right here. So you just double click it and it should open in RStudio if you have that installed.
Which file?
The R Markdown file, so the one that says RMD at the end.
Okay.
Cool.
Wait, I am lost.
Yeah, same. But I think I'm gonna have to go watch this video because I'm just trying to take notes.
Yeah, that's fine. I mean, you guys can, I follow along if you can because it's gonna get really cool, but you can always come back to it if you need to do that. Is there any problems that are like, we think we can fix right now? Because if we can do that, then we can get everyone
I
going.
just don't even know what I don't know, honestly. I'm just taking notes.
So it's just download the file, unzip it, and then double click on the .rmd.
Yeah, and it should open in RStudio. Did everybody's that open in RStudio?
Yeah. see your name on it.
I'm gonna download. I might need help downloading RStudio like after this info.
Yeah, that's fine. And yeah, we can go through the video. Like you can go through everything, but you'll see cool stuff. Okay. So this is one of these markdown documents. So this first part just gives you the title and author, and you can see what I mean here when I say that these are chunks and this is text. So if you look at the, this is like the published version of the tutorial, you can see that it prints the the title here, prints the name here. Then I made a little heading that said created for this meeting. You can see how that's bigger. And then just a body text, and I did the first instruction. So you can see that when you actually like knit this together, it creates like a mix of code chunks like this and actual annotations so that you can share it with other people and they can see what you're doing. Some things that you need to include in these chunks are that I didn't want this chunk to be displayed, so I put false here. So as you can see, it's not displayed here. This one I wanted it to include, but I didn't want it to actually run on my computer because I already have these libraries installed. Okay, so the first thing you guys are gonna do is click this play button right here. And then when you're done with that, click this one and let it install all of the packages. It might take a minute.
Did anyone else get an error?
What error did you get?
I got no.
I got an error.
no package called knitr.
Yeah.
ITR.
Me too.
Okay. I actually don't think you need this for the purpose of this tutorial because this is just about making these documents like I uploaded to GitHub. So try running this one and see if it works. And if it does, then I don't think you need to do that right now.
Okay, that worked.
Yeah.
Mine's still running.
Still running, but it looks like it's uploading.
Yeah, it might take a minute. Okay, then, so basically this installs those different packages that I was telling you about. And the first time that you ever run a, like a function from one of these packages, you're gonna have to install it. But after you install it, you don't need to install it ever again on your machine, really, on your computer, unless for some reason it gets uninstalled. But you do need to load these libraries every time you open R. So just because you loaded a library and used a function from it last time, it won't automatically bring it back up the next time you open R. So in addition to installing them, now click this to load all of the libraries. You should get a message like this.
What do I click to load?
Just the same button here.
Oh, under libraries.
Yeah. Everyone do that?
Mine's still yeah, downloading the package.
Mine as well. Still.
It took a long time on mine too. I wonder if it's because so many people are on the internet right now.
Yeah, mine's still downloading, and when I click load libraries, it won't do anything until I think the packages are downloaded.
Yeah, they have to install first. Okay, we'll wait just a couple minutes because I don't want to get too far ahead of everyone. Whose package is installed already? Nobody's? Oh, dang. Okay, I'll wait. We'll fast forward this part. But they're looking like they're installing, right?
Yeah.
Moving very slowly.
Interesting.
Does the green line on the left actually indicate like which line it's going through? So it goes in order. Okay. So in that case, like mine is stuck on number 21.
Mine's approaching 21, but it's been stuck there.
Okay.
Mine's approaching 22, but stuck.
Oh, okay. Ooh, you're ahead.
I wonder also if it's because we're all trying to download these at the same time.
And we're all connected to the same CRAN. No.
Yeah, we're all connected to the same CRAN, and it goes into like whatever it goes into and pulls these out from the internet. So,
Oh no.
but I feel like they've had way bigger tutorials than this one, and it's from the,
Yeah.
like, the library tutorials. Mine did it really fast, but I think I had already installed all these before.
Do I have to enable them after they're installed, like on the right-hand side?
No, so that's what this load thing is. So you can also do it if you click them here. That will enable them, but it's much better just to load them here, because what you want with a script is you want somebody else like you guys to be able, like be able to give this script to you guys and run it and for it to work. Whereas like if there's a lot of things that you have to point and click and do, then that's not going to be written down, basically. Like it's not going to be as reproducible. So you want to minimize the amount of point and click things you have to do. What else can I tell you right now?
Mine's still stuck at 21.
Oh, really?
Mine is.
Yeah.
Well, we might have to just have me show you.
I'll
guys.
watch you.
So much more fun if you can do it yourself.
Well, could we watch you and then maybe next lab if we can do them?
That's true. Yeah, okay.
Yeah, because I can't even do anything right now because I don't even have R or R Studio downloaded, so I couldn't follow along anyway.
All right. Yeah. Okay. So the next step that we're going to do is importing the data set. So this is actually like a hard kind of step, like for people who've never used any kind of programming language before. So this is the object, and this little arrow sign is assigning whatever is on this side to this object. So when I click this, it's going to read in my data. And how this works is when you're working in R, you have a working directory. And so if I wanted to know what my directory is, I can type get wd. And I can see right now that my working directory is users Emily desktop tutorial. So anything that it's going to pull is going to pull relatively from this directory. So the good thing about R Markdown files is that they set your working directory as soon as you open them to the folder that they're in, which is really nice, because that means that if you're working with a file here, all you have to put to import this data file is the name of the file. You don't have to put the full path name. Like if I had to put the full path name, I would have to put this whole path, users Emily desktop tutorial data thing. But I don't have to do that because our Markdown is making my working directory this folder that it's in already. So all I have to do is this. So then I can see that my data has been imported, and I can see it's 100 observations with 6 variables. So if I click on that, it pulls it up and I can see what my data looks like. So I can see the participant number. So this is like your participant ID number, their group, which in this case, I simulated this data to be like early stress versus not. So the zeros are the comparisons and the ones are the early stress group. Sex 1, 0, I did 0 male, I think, and 1 female. Age, then anxiety percentile and depression percentile. This is like a typical data set that you might extract from one of the questionnaires for one of our studies. Okay, so the next thing we want to do is check and see what our variables are. So one way that you can do that is okay, so the way that R like reads variables is you type in the data frame, then the $sign and the variable. And that is like targets that variable within the data set. So I need to find out, I want to find out what type of variable my group variable is, right? So I'm going to do, I don't think it's type. I think that's Python, isn't it? I legit don't know. I might have to Google it. What is class? Okay, it's class. So I'm going to type class, my data frame, and my variable. And see, when I type a $sign, RStudio really nicely brings up all the variables in this data set for me. So I can click enter. And it'll tell me that that's an integer because it's reading it as 0 ones, right? But we don't want it to read it as 0 ones because this is a group that we're going to be using to separate our data into different bins. So I want to factor it. And one easy way to factor it is just to do, I'm assigning. So when you do this, it's basically going to go into the data frame and add a variable. When you put the $sign on the left side of the assignment thing, it adds a new variable to your data set and it will add it to the end, okay? But if you already have a variable in your data set called group, it's gonna replace that. So I'm replacing the variable group with the factored version of the variable group. Okay, so I'm basically replacing it with itself, but as a factor.
And
So,
what does factor mean?
Factor means like a categorical variable. So like early life stress or comparison or male, female, or something like that, where there's like distinct categories and not a scale of numbers.
Okay.
So, okay, so, and R is pretty good. Like it will usually do this for you, but if you want to make graphs, you usually have to set it yourself because otherwise it might not know what to do with it. Okay, so another thing you can do is press Command Enter for a single line, and it will run just that line. So unlike Python, which runs things in cells, R runs things line by line. So you can, and it runs things from left to right. So you can run one line at a time by pressing Command Enter. Okay, so I just ran that line. So now let's check and see if it's now a factor. And it is, because you can see it's, well, actually I'll do class. Class, it's class right here. You can see it's a factor now. It says it's a factor. So that's good. That's what we want. Here I'm basically doing
a factor because it says 0 and 1.
Yeah, but also here when I say class of that variable, it tells me that's a factor. So that's what we want. So here I'm basically doing the exact same thing, except for I'm factoring it and I'm also setting labels for the levels. So we have 2 levels in this factor, 0 and 1. And so I'm setting them equal to comparison and ELS, the word, so that we will know in our graph which is which.
So
like
you wouldn't be able to do that unless you set it to factor. So if they were as integers and then you tried to label the levels, that wouldn't happen, right? Because it would come back saying like you can't label an integer.
Yeah, I'm not sure exactly what it would say. There is a way to do it. Like you can set if variable is equal to 0, make it this string.
Okay.
You can do that, and then it will probably treat strings as factors automatically.
Okay.
Yeah, but this is a little bit easier, I think.
Yeah, it's easier just to like turn it into a factor first, and then define the levels and create the labels.
Yeah, I think that's a little easier. But you could do 0 equals comparison or whatever.
Okay.
Yeah, and as you'll find with programming, there's a ton of different ways to do
different
stuff.
ways. Yeah.
And they all work. Some are just a little bit easier than others. Yeah. Okay, so I'm basically just gonna do the same thing but I'm also going to label them here. So you wouldn't need to do both of these, but I'm just going to do it for an example. See, now I can see that it's replaced my binary variable with the actual
Nice.
name that I want.
That's what we want.
Cool. So now it's the fun part. So I think that the first thing you should do when you analyze data is actually look at it, because it's really easy to run a test or a statistical model on data and have no idea what it actually looks like. And you might be running the completely wrong thing because it might not be what you think. So I think the best thing to first do is to plot your data. So there's this amazing tool in R called ggplot, which is like just amazing. You can do so many things with it. So I'll explain the basic syntax of it. Well, first let's run it. I'll run it and show it to you guys, and then I'll explain what each part does.
And you said this is just to look at the data first?
Yeah.
Okay.
So super exciting. Look at that. Looks like our ELS group definitely has higher anxiety than our comparison group, right? So we can see that this is the mean. These are box plots. So this is the interquartile range, and this is the variation between all the data. So the way that the syntax works for this plot is you feed in, first I assign it to P for plot, because I want to be able to have that as an object. Then I feed in the data that I want to create it from. Then I map the aesthetics. So AES means aesthetics. You map on the X variable and the Y variable. So it's always XY. So I want my group to be at the bottom on the X axis, and I want my anxiety to be on the Y axis. Then fill means the color of the bars. So basically I want these to be filled in a different color by the group. So I want the groups to be filled in a different color. So that's why I put fill equals group there. Okay, so the way ggplot works also is each plus sign means you're adding a layer onto your plot. Okay, so that I just basically made the plot with no box plots on it. Then here I'm gonna add geom box plot, and all of the elements that you add to your graph are generally called geoms. So you can have a geom point, geom line, geom histogram, a bunch of other things to create the types of graphs that you want. So actually, let's try to do it like one by one and see if it works. Okay, so see, when I just have this, I've just made my graph, basically. I've made my graph with the X and the Y axis, the variables, and the two groups. Okay, so now I'm gonna add my geom box plot thing so that I can add the little box plot on. Okay, so now I added my little box plots, but there's like some other things here that I like don't really like, and because I put the color here, it automatically does the color. You can do the color either here at the very beginning, or you can do it inside the element itself if for some reason you want to color it differently based on the layer that you're in. Yeah, but there's some things here I don't like I don't really like this legend because we already know what groups and my variable names are. Huh?
What's layer? What do you mean by that?
So basically you can think of like that first part was one layer of the image, and then it added on another layer that was just the histograms themselves. So it like stuck those on. So every plus sign in the ggplot syntax is like adding on like another thing on top of that thing. So you can add a bunch of different stuff that you want to add to it based on your data. Yeah, so here you can see it comes out exactly as you've labeled your variables though in your data set. So see how they're like lowercase and it's like got an underscore and like I don't really like that. So I'm gonna format my titles and axis labels So that's really easy. You just do GG title, the label that you want, and the X label and the Y label that you want. Okay, so if I run that, okay, cool. So now I've got my title and this, but now I want to get rid of this legend because it's kind of redundant. So now I'm just going to add one final layer. Oh, and in the layers, you can get rid of things and you can add things. So they're a little bit more complicated than actual, just like thinking about layers, but you can think of like it kind of masking something else maybe. Okay, so then if you do theme, legend, position, none, that'll get rid of the legend. So now you have this cool graph that looks like you want it to, which is really nice.
And theme refers to what?
Theme refers to like, there's a few different themes that come with basic ggplot. So like this is the basic one, the default. You can add theme black and white and it converts it to like a black and white graph like this. Theme line draw where it's just a basic line graph. Theme light. So yeah, you can add a bunch of different themes to it. And one of the coolest thing is being able to change colors by adding palettes. So there's this, and there's tons of like little add-on type things from other people where you can add different colors. So this is these are Wes Anderson palettes from Wes Anderson movies. And they have like all these different cool colors. This part's really fun and a lot of waste of time because it doesn't actually matter what color your graph is, but it's super fun. So I had to do it, obviously, for fun. So look at that. How cool is that? This is Grand Budapest 2 theme palette. But there's like so many. So you just basically change the word that's here and it will, so like let's try one. Okay, which one do you guys want to do? Should we do this one?
So you have to type theme just to change the color, or it'll automatically put theme on there? Or is that part of what we need to do to make the graph? Or that's just the color?
It will put the theme based on whatever theme you choose. You just have to type in the name. But it has to be a theme that's obviously like in this palette because it's a package that I added onto it. So now if I do that, so now it's like a totally different color, which is cool. And here you specify how many colors you want. So like this palette has like this many colors. So you specify, I have two bins, so I only need 2 colors. And then it takes the colors from that and applies it to your graph, which are really cool when you have like a bunch of different things that you need to be different colors. So yeah, so the next part, so okay, so we've now plotted it and we can see that it looks, right, like the ELS group has higher anxiety than the comparison group, right? But we don't really know that for sure because we just, and I'm almost done, we just plotted it, right? So we have to do a statistical test now to see if that difference in the average, in their average, is statistically significantly different, right? So the way you do that, and it's super easy in R, as difficult as R is for like data cleaning and scripting, it's super easy for analysis because, so I want to do a t-test. This is all you have to type. T.test, the outcome variable, so anxiety percentile, by a little tilde thing, the group. So I want to look at differences in anxiety by the 2 groups that I have. And then my data frame. So that's super easy. Dog. So Nicole, you were showing me your script earlier and you had made 2 separate data frames for your different groups, which is totally fine. You can definitely do it like that. This is another just easier way to do it. There's like lots of ways to do it though. You can, subset your data out so you have like a data frame of early stress and a data frame comparison and then run the means of those 2 data frames against each other. Yeah, there's a lot of ways to do it. So then you're just going to press this little button. And then it gives you this output. So really quickly, I'll just go over what this output means, and then we'll be done. Okay, so the first thing actually you want to look at is the bottom. So here I can see that the mean of the ELS group on anxiety is 77. And I can see here that the mean of the comparison is 51. Okay, so it's just your basic t-test, two-tailed t-test. What I'm interested in is this difference actually significant, right? So then the next thing you want to look at is probably your p-value. This is in scientific notation, so this is an extremely small p-value. It's like 0.00006 14 times, which would never actually happen. I made this data, so that's why. And this is
a smaller p-value is better or worse?
Smaller is better, yeah. I mean, I don't think you would ever see that in, I mean, maybe in like some repeated measures designs, but like you're not, yeah, that's really low. So yeah, you're not really gonna see that. But you know, what you choose to be your p-value is kind of arbitrary. They say like less than 0.05 is like what you want, you know, but and basically what this is testing, so this is your t statistic. So you probably remember from stats class that the test that this is actually doing is right here. So this is your alternative hypothesis. So the true difference in both of these means is not equal to 0. So if the true difference were equal to 0, then that would be that we don't really know if the difference between these two means is the same or not, right? Because it's equal, it could be equal to 0. So right now it's looking like the difference is 77 minus 51, which is what, 20 something? So we think the difference is around 20, but it could be anywhere, and this is where our confidence interval comes in. So given these data, we can think that the average difference between these two groups is most likely between -31 and -19. And that just means that this one is gonna be 31 to 19 lower than this one, based on the data that we have with this test. So if this wasn't significant, this would go past 0, right? So it might be like -30 to +20, and that means that the true difference in the two means in the population could be anywhere from -31 to +20. So we don't know, like, are they the same? Are they different? We don't know, because 0 is encapsulated between that confidence interval, if that makes sense. This is like one of the hardest things to understand though, so we should probably do like a separate tutorial on that. But yeah, and this is your degrees of freedom. So it's just talking about it's a calculation based on your sample size. And then, yeah, that's pretty much it. So it's very, very easy to do analysis in R. It's really as simple as typing t-test anxiety group data. Yeah, and then just learning how to interpret this. But it's pretty simple. And yeah, that's it. Any questions on this?
Yeah, for the code you wrote for t-tests and anxiety _ percentile, is that a dash, like a hyphen?
It's a tilde, which is like the little squiggly dash.
But then how does it know that you're looking only at group? Oh wait, I see it. Never mind. So What does the tilde mean again? It's referring to not a variable, right?
No, it usually in R means as predicted by. So this is looking at anxiety percentile as predicted by group.
Okay.
So you can also use the same tilde for regression. So if you wanted to say regression as predicted by specific variables, you'd use that same syntax, but in a different argument function. Yeah. Cool. Any other questions? It's easy, right? That like the analysis. Plots are a little bit harder, but they're also really cool. So I like to start with those.
I kind of followed.
Cool. Well, I think
Thank you for explaining.
Yeah. So let me know what you guys want to know next. Like, would it be more helpful to talk about like stats or plotting different kinds of things, or I don't know.
test to run, like what kind of test to run if you want to find out.
So that's a good one.
Mhm.
Yes.
That's a really good one, actually. So maybe next week we can do statistical decision trees.
Yes.
Ooh, yeah. Yeah. Maybe I'll make a calendar. I'll transfer the lab meeting calendar to Box, and then I'll make a calendar for RA meetings, and you guys can like sign up on there, or we can write ideas for what we want Emily to teach us every week.
And seriously, try this once your R is working because it's so fun, and try like some different colors because it's super fun.
Mine's still stuck on 21.
Really?